Welcome all. In last lecture we have seen the serial input, serial output register, serial input, parallel output register, parallel input, serial output register, and parallel input, parallel output register. Today we will see what is a bidirectional shift register and a universal shift register. First of all, we will see what is a bidirectional shift register. Now, if a binary number is shifted left by 1 bit position, then it is equivalent to multiplying the original number by 2. If a binary number is shifted right by 1 bit position, then it is equivalent to dividing the original number by 2. So this can be illustrated as follow. If we take a 4-bit number, that is 0010, whose decimal equivalent is 2, is existing in a shift register. Now if we want to add a 0 applied at the input of the shift register, which already consisting of the data 0010, if we shift these contents by 1 bit position to add a 0 towards left, then we get this data as 0100, means here we have shifted this data towards left by 1 bit, by which this 1 is shifted to this position by a 1 bit. We know the decimal equivalent of this number 0100, which is a 4. Now previously, before shifting the given data towards left by 1 bit position, its decimal equivalent was 2. After shifting the data towards left by 1 bit position, it becomes as a 4, means it gets doubled, which can be say that the shift left is equivalent to a multiplying by 2. Now if we take the same example, that is 0010, having decimal equivalent of 2. Now if we want to add a 0 at its input by shifting the given data towards right by 1 bit position, then after shifting the data will be 0001. Before shifting the data was 0010. We have shifted this data towards right by 1 bit position by adding a 0 at its input. It will become as a 0001, whose decimal equivalent is 1. Now before shifting the decimal equivalent was 2, and after shifting the decimal equivalent becomes 1, means this number gets divided by 2, which will results in 1. So we can say that shift left operation is equivalent to dividing by 2. Now hence, if we want to use a shift register to multiply and divide the given binary number, then we should be able to move the data in either left or right direction. When the data is moving in a left or right direction, then such a register is called as a bidirectional register. This is the circuit diagram of bidirectional shift register, which is of 4 bit. Now here the given circuit is a 4-bit bidirectional shift register, which can shift the data either towards left or write having a size of 4 bit. Now there are two serial inputs, namely write shift data input, that is DR, and left shift data input, that is DL, along with mode control input M. This mode control input M will decide whether the data is going to shift towards right or towards left. Now this consists of 4 D flip-flops connected with each other through these combinational circuits. Now all the 4 flip-flops are negative edge triggered flip-flop, means it is going to operate only at the negative edge of the clock pulse. Now we will see the shift right operation. When mode control input M is made 1, then the circuit is going to shift the data in the right direction. Now when mode control input gets 1 input, this line will become having value of logic 1, and this M bar line, this line becomes having value of 0. Now because of this AND gate 1, 3, 5 and 7 becomes active, whereas the AND gate 2, 4, 6 and 8 becomes inactive, as they are having at least one input 0, so their output will be always 0. Therefore the AND gate 2, 4, 6 and 8 are inactive, or they are disabled. So the data which is available over here will be going to shift towards right direction through this AND gate, OR gate, through this flip-flop, through this AND gate, OR gate, through this flip-flop, through this AND gate, OR gate, through this flip-flop, through this AND gate, OR gate, through this flip-flop, and it will be outputted in the right direction. Now when mode control input is 0, means this line becomes a 0 and M bar line will becomes as a 1, means this line is having a logic level of 1 and this line is having a logic level of 0, by which the AND gate 1, 3, 5 and 7 are now inactive or disabled, as they are having at least one input as a 0, so their output will be 0 always. Therefore they are not active. In other words, the AND gate 2, 4, 6 and 8 are having input of logic 1, therefore they will be enabled or they will be active. Therefore the data which is over here will be going to shift in left direction through this AND gate 8, OR gate, flip-flop 0, through AND gate 6, OR gate, flip-flop 1, through this AND gate 4, OR gate, flip-flop 2, and through this AND gate 2, OR gate, flip-flop 3, and over here, that is Q3, we are going to get the final output by shifting the data in the left direction. So with mode control input is equal to 1, then the data will going to shift from flip-flop 3 to flip-flop 0 in the right direction, and when mode control input is 0, then the data is going to shift from flip-flop 0 to flip-flop 3 in the left direction. This is how this bidirectional shift register works. Now this is the circuit diagram of 3-bit bidirectional shift register. Its operation is also same, only here a JK flip-flop is used instead of D flip-flop, and J and K terminals are connected together through a NOT gate. The operation will be same for this. Now we will see the problems based on the shift registers. Now here the problem is how many flip-flops are required to build a shift register to store a octal number 14. This is the one question. A binary 4 bits, this is the second question. A decimal 18 number, this is the third question, and hexadecimal C2 number, this is the fourth one. Now we will see one by one. Now here first octal number 14 is given. First we have to convert it into a binary number. After the conversion of octal number into binary number, we can get a number as a 0 0 1, this is for 1, and 1 0 0, this is for 4. This is the binary number written with 3-bit binary equivalent. So the number can be rewritten as 1100, as these two zeros are not having any significance at the MSB position. Therefore in all there are 4 bits in a binary number of octal number 14. So to build a shift register for octal 14, we require 4 flip-flops. Now after this, the second question is for binary 4 bits. This is a binary number. Already the given number is binary number which is of 4 bit in a size. So for to store the binary 4 bit numbers in a shift register, we require 4 flip-flops. Now we will see the third one, in which the number is 18, which is a decimal number. First we have to find out the binary number of this one. The binary number of 18 decimal number can be converted by dividing it by 2. After the division we will get the number as 10010. This is a binary number which contains 5 bits. So we require 5 flip-flops to construct a shift register to shift or to store the data decimal 18. After that we will see the fourth example, that is the given number is hexadecimal number C2. First we have to convert it into a binary number by writing 4-bit binary equivalent. For C we can write 1100, and for 2 we can write 0010. C means 12, whose binary number is 1100, and binary number of 2 is 0010. Now in this there are 8 bits, so we require 8 flip-flops to build a shift register to store hexadecimal number C2. This is how we can find number of flip-flops required to build a shift register from the size of the given number in a binary format. Now next we will see another example. To shift a given data 1111 into a 4 flip-flop serial shift register, calculate time if frequency is 5 MHz and 2 MHz. Now here in first example, the frequency given is 5 megahertz. So to store the given data in a 4 flip-flops, we will require time 4 times. Means to store a single bit data, we require a 1 clock pulse which is of 5 megahertz. In this way, we require 4 clock pulses to store the given data 1111 as it is of 4 bit in a size. So I have written a time is equal to 40, which can be written as 4 into 1 upon f. Now here we know frequency, that is 5 megahertz, that is 5 into 10 raised to 6. After the calculation, we get the time as a 0.8 microsecond. Now this is the homework which you have to submit it to me. You have to study the IC 7495 which is of universal shift register and submit it to me by the 12th of December.